Alright, in this video, we're going to go over complex numbers and polar form of complex numbers. Alright, so let's get started. For a little refresher, the standard form of a complex number is a plus or minus bi. Alright, don't forget that. The standard form of a complex number is a plus or minus bi. Don't forget that I is the square root of -1, meaning that I squared, of course, equals -1. Alright, don't forget that. Now, let's talk about graphing complex numbers. Alright, when you graph complex numbers, your axes look very similar to your rectangular coordinate axes, where you have an x and a y. But instead of x and y, this is your real axis, and this is your imaginary axis. Okay, so if you wanted to graph a complex number, say you wanted to graph 3 plus 2i, okay, so you want to graph 3 plus 2i, so you'd go over 3 on the real, and then up 2 on the imaginary. So that right there would be 3 plus 2i. Okay, so you graph them much like you would rectangular coordinates. All right, you graph them on your complex plane, and you go right or left depending on if this is positive or negative. You go that many units over, and then you go up or down depending on whether this is positive or negative, however many units is here. Okay, so graphing them is not too bad. But let's also talk about how to find the absolute value of a complex number. Now, the absolute value of a complex number is simply the distance from 0. All right, so it's simply this distance right here, okay, from the origin to your point, okay? To find the absolute value of a complex number, you have the absolute value. Let's use the point we just plotted, 3 plus 2i, okay? What does that equal? Well, your equation, or your formula, is the absolute value of a plus bi is simply the square root of a squared plus b squared. All right, it's simply the square root of a squared plus b squared. So this is going to be the square root of 3 squared plus 2 squared. So that's going to be the square root of 9 plus 16, which is the square root of 25, which is therefore 5. Okay. Whoops, I have 2 examples, and I did the other example. I didn't do this one. Well, let's do this one. Sorry about that. This is going to be the square root of 9 plus 4, which gives you the square root of 13, and of course that does not reduce. So the absolute value of 3 plus 2i is the square root of 13. All right, it is the square root of 13. The problem I just did, that I erased, is I found the absolute value of 3 plus 4i, which is 5, like I just worked out. That's another example I had in my notes to do, but I ended up sticking with just the first example. Okay, so it's just simply a squared. Remember, a is your real term. Okay, it's the real part of your of your complex number. And b is the coefficient on your I term. So 3 is a, 2 is b. Down here, 3 is a, 4 is b. Okay, so not too bad. Just simply square root of a squared plus b squared. That's just distance formula or Pythagorean theorem, however you want to look at it. All right. Now let's talk about polar form of a complex number. All right, polar form of a complex number. If you remember, standard form was a plus bi. That's standard form of a complex number. Now we're going to convert that into r, because you got to have a radius, times CIS theta. Okay, R times CIS theta. This is the shorthand way to write it. The longhand way to write it is R times the cosine of theta plus I times the sine of theta. Okay? If you write it the shorthand way, though, because these two thetas are always going to be the same. They're never going to be different. So it's just cosine I sine. So CIS. Cosine I sine, that's where they get the CIS from. You are always allowed to write in shorthand in this class. All right? You are always allowed to write the shorthand in this class. I'm not going to make you write this one out. You may see this form on a test, so you need to be able to recognize the longhand form of it. Okay? You need to be able to recognize the longhand form. But if I ask you to write this, it's perfectly okay to just go ahead and write me the shorthand version. All right? Now, so how do we get these numbers? Well, let's look at our formulas. All right? R squared simply equals the square root of a squared plus b squared. The tangent of theta simply equals b over a. Or for this one, you can say theta equals the inverse tangent of b over a, because that's actually the math you're going to be doing anyway. You know, you're going to set it up and then you're going to do the inverse tangent. So you're actually going to be doing that anyway. So why did I put the square root there? R squared equals a squared plus b squared. I don't know why I put the square root there. Sorry about that. I don't know why I put the square root there. Okay. So when you're going from complex to polar form of a complex number, these are your formulas that you're going to use. If you go the other way, A will equal R cosine theta, and B will equal R sine theta. Okay? So if you're going from complex to polar form, you're going to use this one. If you're going from polar form back to complex, you're going to use this one. Okay? So let's look at an example. I'm going to leave this up here for the example. Okay, let's look at an example. Let's see, what do we got? Let's go -3 plus 4i. That's our example. Let's put this into polar format. Remember, that's RCIS theta. Okay? So we can find R first if you want to. Remember, R squared equals a squared plus b squared. So it's going to be 3 squared, because when you square a negative, the negative is really pointless, plus 4 squared. Okay, 3 squared plus 4 squared. So R squared equals 9 plus 16. So R squared equals 25. So we want to find R, so square root both sides. So R equals 5. Okay, R equals 5. Remember, it can be plus or minus, because depending on our angle, we may have to use a negative radius. Okay, so just keep that in mind. Now let's find theta. We know theta is going to be the inverse tangent of b over a. Okay, b over a, so it's going to be 4 over -3. Punch that in your calculator. You should get -53 degrees. Okay, you should get -53 degrees. Now, before we start to fill all this in, let's figure out if this angle and is in the right spot, and what radius we need in order to hit our point. Okay, so here we go. If we were to plot this point, it'd be -3, 1, 2, 3, positive 4i. So our point's going to be right here. Well, our -53 degree angle is going to be right here. This is going to be -53 degrees. So if we want to use the negative 53 as is, which is completely okay, we're going to have to use the negative 5 in order to get to our point. Okay, so remember, just like when we were taking rectangular coordinates and converting them to polar, you always want to make sure you check your angle and your radius to make sure what you write will actually hit the point that you were given. All right, so we need to hit this point that we are given. So if we want to use our negative 53-degree angle, we have to use a negative r, so that way we go backwards and we can actually hit this point right here. Okay, if you wanted to use a positive angle, if you wanted to use a positive angle and a positive radius, you could go 5, but then CIS, you'd have to come up with a different angle. Well, we know that our reference angle right here will be 53 degrees. So 180 minus 53 gives us 127 degrees. So both of those points, both of these right here, and of course there's 2 more ways to write this, because remember there's 4 ways to represent a point in polar format. And that's what we're doing, is we're representing a point in polar format. So we have 2 more ways that we could write it. But both of these correctly, well, I didn't mean to write that. Both of these correctly represent that point right there, negative 3 plus 4i. You can either use negative 5 CIS of negative 53 or 5 CIS of 127. Okay? All right. I want you to try this one. See if you can do it. I want you to take z equals 7 CIS of 215 degrees, and I want you to put it into a plus bi format. All right, so pause the video and put this one in a plus bi format. Okay, that should have been enough time. So now let's put this into a plus bi format. Okay, so we know that a is going to equal r times the cosine of theta, and we know that b is going to equal r times the sine of theta. Okay, so a is going to equal r, which is 7, times the cosine of 215 degrees. Punch that in a calculator, you should get negative 5.73 degrees. And then b is going to be 7 times the sine of 215. So punch that into your calculator, and you should get out negative 4. Well, let's go 0.02. Okay? So now, what we need to do is we need to check to make sure we're going to be hitting in the right place. 215 degrees is going to be in this quadrant right here. Okay, and our point is going to be out here somewhere. Well, negative and negative, 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 we're going to be in this quadrant as well. So we can use, I don't know why I put degrees on those. They're not angles. Okay, so we can use these numbers as is because we just double checked it, and in fact, the 2 numbers we got represent this point perfectly. So writing 7 CIS of 215 in a plus bi format is going to be negative 5.73 minus 4.02i. All right, that is how you convert between the 2 different formats, polar format or a plus bi format. All right, the main thing to remember is make sure you wrote down those equations correctly. Let me go back to them. Make sure you have r squared equals a squared plus b squared. Make sure you have tangent of theta equals b over a, or theta, of course, will equal the inverse tangent of b over a. Make sure you have this written down when going from complex to polar. And make sure you have this one written down from going the other way. A equals r cosine of alpha, and b equals the r sine of alpha. Don't forget the shorthand and the longhand way. You only have to ever write me the shorthand in class, but you do need to know how to recognize the longhand in class. And other than that, I mean, there's not too much to it. You just simply follow your formulas, and you're good to go. Okay, feel free to watch this as many times as you need to. Make sure you come to class tomorrow ready to work some problems. See you tomorrow.